Okay, I'll probably try to edit this. All right, here we go. So this is a review video on how to break down vectors into their horizontal and vertical components so that we can use the components of vectors when we are analyzing motion in 2 dimensions, analyzing forces, or even adding a lot of vectors all at once. And the vectors in like different, that they're not always just perpendicular or parallel. So I want to remind you that we already learned how to add vectors together, whether they're pointing in the same direction, opposite direction, or exactly perpendicular. Remember, the resultant of a vector is a sum of 2 or more vectors. So if you need to review these, please go back and review the poison arrow notes. And so also want to remind you that we have been reviewing right triangle geometry. We're going to be using that more when we're breaking up vectors into horizontal and vertical components. And so reminder that we're going to be using the SOHCAHTOA, which is, remember, sine of an angle, cosine of an angle, and tangent of an angle are a relationship between the sides of a right triangle and a specific angle for a right triangle. And that there are some special right triangles that we won't necessarily have to use a calculator, but if we remember that these special right triangles have unique relationships between the sides of the triangles and the angles that make up that triangle, then that might make analyzing vectors, breaking them into components, easier. So what does it mean when we're breaking up a vector into its horizontal and vertical components? So every vector can be broken into a horizontal and vertical component. So these components are on the axes are called rectangular components, and it's the sum of a vector's components equals a vector. So basically, in math class, I'm going to write over here on the iPad screen. You might remember when you're younger, in math class, you would take a number and your teacher would say, factor that. What 2 numbers multiplied together will equal that number. So one example of a factor of 24 is 2 and 12, right? And another way we can factor 24 is we could do 3 and 8. And even more, another factor of 24 is 4 and 6. So we took that number 24 and we found what 2 numbers, when we multiply them together, make up 24. The same is true about vectors. We are going to be given a vector and we want to know what 2 vectors that are perpendicular to each other add up to equal the resultant vector. So if I have this vector r here, and then with an angle theta, what horizontal vector and what vertical vector am I adding together to equal that vector? So what we're doing is, we'll go back over to this side here, is I'm taking this red vector and pretending like it's the hypotenuse of a right triangle. And so then I'm breaking it up into its horizontal piece and then a vertical piece. And so these 2 blue vectors are perpendicular to each other, and I can add those together and get the resultant vector. So how does that work? What's that relationship? So again, I'm going to draw a new vector here. So I'm going to take this vector here, r, and that vector makes an angle with the horizontal axis. That I'm going to measure this angle from the horizontal axis, and that's going to be giving us our vector theta. So I want to know what is the horizontal vector that I can add to a vertical vector that will equal the purple vector. So the horizontal vector rx added to the vertical vector ry will give us the resultant vector r. So here's where our right triangle geometry comes into play. And so I'm going to say that my rx, let's just do back to the geometry part. So sine of an angle is equal to opposite over hypotenuse, and cosine of an angle is equal to adjacent over hypotenuse. So when I'm looking at just the angle theta, sine of theta is equal to, our opposite side is ry, and the hypotenuse is called r, and cosine of theta, our adjacent side is called Rx, and our hypotenuse is R. So if I wanted to solve those equations for each Rx and Ry, I'm just going to do a little, algebra. So Ry is equal to R times the sine of the angle, and Rx is equal to R times the cosine of the angle. Now, I can always do this, use these two formulas whenever my angle is measured from a horizontal axis, or the x-axis, whether it's plus x or minus x. So let's add some numbers here, and let's change these now. And let's give this a number here, make this not so big here. So now my purple vector, let's give it, let's say it's got 25 meters per second, and let's let this angle be 53 degrees. So now all I need to do to figure out the horizontal and vertical components is substitute in 25 and 53 for r and theta. So now I'm going to do it in a different color. So then my Ry is equal to 25 times the sine of 53, and my Rx is x is equal to 25 times the cosine of 53. So I picked this angle and this length because I know it's a special right triangle, so I don't have to break out the calculator. But you're going to plug into your calculator 25 times the sine of 53, and you should get Ry rounded to the nearest whole number is 15. Now the units are meters per second. And when you plug in 25 times the cosine of 53 in your calculator, you'll get 20 meters per second. Okay? So that's how you would break that vector up into its horizontal and vertical components. Okay? So I'm gonna do another one, and I'm gonna make it a different color. So let's use bright green, or this green here. So now I'm gonna erase this one, and you're gonna try to do one on your own. So I'm gonna give you, let's pick, now this is purple vector is gonna be 10 meters per second. And we're going to say this is 37 degrees. So I want you to follow, I'm going to put a little box around it, follow this formula here. If you are comfortable just plugging the formula, or if you're not totally comfortable, then maybe you want to go back and use these relationships and set that up. So you can solve all that doing it that way, or plug in the numbers into that. All right, so pause the video and try to determine what the horizontal component and the vertical component of 10 meters per second at 37 degrees would be. All right, so hopefully you did the following. You said Ry is equal to 10 times the sine of 37, and Rx is equal to 10 times the cosine of 37. And so then that means that Rx is equal to, rounded to the nearest whole number, 8 meters per second, and Ry is equal to 6 meters per second. Now I did this really fast because I specifically chose a special right triangle. When I see this special right triangle, this happens to be a 3, 4, 5 right triangle. This is 5 times a number, so 10 divided by 5 is 2. So this side is 4 times 2, 3 times 2, 5 times 2, or 3 times 2, 4 times 2, 5 times 2. So then if this is 3 times 2, it should be 6. And if this is 4 times 2, it should be 8. It's just one of those special right triangles that I memorize. Okay? So that's how you break up vectors into their horizontal and vertical components. And if we were to have a chain of vectors, let's say we're adding this vector to this vector to this vector, right? To add that chain of vectors, mathematically, we would need to determine all the horizontal and vertical components of each of those vectors, add up all the horizontals, and then we would get one big giant horizontal component, and then add up all the verticals, and we get one big vertical component, or little, I don't know. And then we would be able to do what we did a couple days ago and figure out, using Pythagorean theorem, the magnitude of this vector and the angle. Okay? All right, that's how to break up vectors into components. If you need more help, please come into tutorial and get some support.